2017. Okay. So here we have an ellipse that has major axis equal to 4a. That means 2a is 4. 2a is the major axis, 2a is 4, and the minor axis 2b is 2 units. That means a is 2 and b is 1. Right? And it is slipping. In fact, you could say it is rolling without slipping. It is rolling without slipping between the coordinate axes in the first quadrant while maintaining contact with both the x and the y axis. That means at all times the x and the y axis are tangents to the ellipse. So the variable ellipse is like this. Okay, the physical features of the ellipse is not varying because it's the same ellipse. Same major axis, same minor axis, and so on and so forth. But the major and the minor axis are rotating, are getting tilted. They are getting reoriented, but the physicality of the ellipse will remain the same, barring its orientation. Okay. Now, at a certain instant, let's say, the ellipse looks like this. At a certain instant, these are the points of tangency. All right. Now, so if this fixed ellipse is slipping about the x and the y axis in a manner maintaining its major and minor axis, the center of this ellipse is moving to different positions. There is a locus associated with the center of this ellipse. We seek to find the locus of the center of the ellipse. Okay. Now, first of all, realize that this is the major axis of the ellipse. This is the major axis of the ellipse. This is the major axis of the ellipse. And on the major axis, the center C lies. The center C has coordinates h comma k. Right? So, while the ellipse moves with the x and the y axis being tangents to the ellipse at all times, realize that as far as any position of this ellipse is concerned, the origin O is a point that the tangents drawn to the ellipse are always mutually perpendicular from O. The two tangents from O for all positions of the ellipse will be mutually perpendicular. That means at all times O must lie on the director circle of the ellipse. Right? Even though the ellipse occupies newer and newer positions, O will lie on the director circle of all these positions. Right? So O lies on the director circle. Now, if A is the semi-major axis, B is the semi-minor axis, then the radius of the director circle. First of all, the director circle shares a common center with the ellipse, and the radius of the director circle is always root a square plus b squared, is always the radius of the director circle. Now, for the director circle, this C of the ellipse will also be the C of the center of the director circle. And do you realize that the radius of the director circle will be OC? The radius of the director circle will be OC. That means at all times, C will move in a manner that OC squared will be A square plus B squared, because O lies on the director circle. Distance between O and C will be the radius of the director circle. That means OC would always be, OC squared would always be A square plus B squared, which is square of the radius of the director circle, right? But OC square is what? H square plus K square is A square plus B squared. A squared is 4, B squared is 1. So that makes it 4 plus 1, 5. Generalize this to get the locus of the center of the ellipse. Replace h by x and k by y to get x square plus y squared equal to 5. That's the locus of the center of this ellipse. Yes or no? Right? Now, having said this, the locus of the foci of the two ellipses. The locus of the foci of the two ellipses. Right. Can I wipe this off? See, if this is one focus, say, let me draw a fresh figure. Say if this is one focus, this is another focus. All right. These are the two foci, say, S and S prime. Now, if S has coordinates h comma k, then its perpendicular distance from the y-axis is k, right? And if the perpendicular distance of S prime is k prime, if the perpendicular distance from S prime is k prime, then do you realize that the product of the perpendiculars drawn from the two foci onto any given tangent is square of the semi-minor axis? Is the square of the semi-minor axis. In this case, A had turned out to be true, B has turned out to be 1. So k into k prime must be b squared. A property, product of the perpendiculars from the two foci onto any given tangent would be square of the semi-minor axis. So k into k prime would be b squared. So k prime would be b squared by k, the y coordinate of S prime. So y coordinate of S prime is going to be b squared, which is 1 by k. Right? Now, again, in exactly the same way, these are S and S prime. If S has x coordinate h, y coordinate k, and S prime has x coordinate h prime and y coordinate k prime, then do you realize on this tangent, the product of the perpendiculars would be from S onto the y-axis would be h, from S prime onto the y-axis would be h prime. So h into h prime, where h prime is the x coordinate of S prime, h into h prime would be b squared. So h prime would be 1 by h. Yes or no? Right? No? Product of the perpendiculars onto any given tangent from the two foci is always square of the semi-minor axis. Right? So h into h prime would be b squared. B squared is 1, so h prime is 1 by h. Right? So which means if one focus S is h comma k, then the other focus S prime would be x coordinate 1 by h and y coordinate 1 by k. Right? And the distance between the two foci would be 2ae. The distance between the two foci will always be 2ae. Now, what is e squared here? E squared is 1 minus 1 by 4, which is 3 by 4 is e squared. And distance between S and S prime, square of the distance is h minus 1 by h whole squared plus k minus 1 by k whole squared is 4a squared e squared. In fact, b squared is a squared into 1 minus e squared. So very clearly you didn't even need to know e separately. A squared e squared, a squared e squared is simply a squared minus b squared. That means 4 minus 1, 3. That makes it 12. Yes or no? All's good? I hope you realize that is 2ae whole square. So 4a squared e squared and a squared e squared is a squared minus b squared, which is 4 minus 1, 3. 3 into 4, 12. Right? All that you need to do is generalize. And realize that the middle terms will get cancelled, giving us h square plus k squared plus h squared, 1 by h squared plus 1 by k squared is, and then 4 from here equal to 16. Generalizes, replace h by x and k by y. So x squared plus y squared plus 1 by x squared plus 1 by y squared is 16. That's the locus of the focus. Got me? So if it's the locus of S, why do you think it will also be the locus of S prime? Because, see, in this case, replace x by 1 by x and y by 1 by y. This will become 1 by x squared plus 1 by y squared is x squared plus y squared equal to 16. So, yes. No, reciprocity is enjoyed here. Replace x by 1 by x and y by 1 by y. Right. So the locus of the two foci will be this only. Got me? And in fact, you know, if you had identified that the locus of the two foci, the combined locus of the two foci would be such that, you know, replacing x by 1 by x and y by 1 by y, the expression should remain the same, then you could have solved this problem just by checking on options, because only one option gives you that possibility, which is option Delhi. No other option will give you the same prospect of replacing x by 1 by x and y by 1 by y, giving you the same entity. That's not happening in other options. Got me? So then, if you had just quickly identified h and 1 by h, k, 1 by k, then the option business would work effective. You didn't have to do all these calculations. Clear? Okay, let's move to the next problem. Comprehension 2. There is an ellipse S1 which is x squared by a squared plus y squared by b squared, which is given to be a squared into 1 minus e squared equal to 1. This is the ellipse. There is a parabola, so let me draw the ellipse. This is the ellipse. This is the major axis of the ellipse. The center of this ellipse is very clearly 0, 0. One focus is, let me call it F1 and F2, otherwise S and S prime have been used in a different context here. So F1 is AE0, one focus. The other focus F2 is minus AE0, right? This is the ellipse S1 equal to 0, right? And there is a focus, there is a parabola confocal with the ellipse. See, this is the y-axis and that parabola lies to the right of the y-axis. The parabola lies to the right of the y-axis. And it has the same focus as that of the ellipse. That's the parabola. Let P be the intersection of the parabola and the directrix of the ellipse in the first quadrant. This is the directrix of the ellipse. What gives us the directrix of the ellipse? X equal to A by E. And this point is referred to as P, the point of intersection of the parabola with the directrix of the ellipse. And L equal to 0 be the directrix of the parabola. L equal to 0 is the directrix of the parabola. Now, if this is the parabola, realize that the parabola, this parabola is of the form y squared equal to 4 into a into x. That is AE in this case. That A is AE in this case. Isn't it? Distance between the vertex and the focus is AE. So, the equation of this parabola is y squared equal to 4 times this distance, which is AE, into x. That's the equation of the parabola. That's the equation of the parabola. Now, the directrix of the parabola will be such that C must be the midpoint of this. C must lie halfway between the directrix and the focus. That means the directrix of the parabola must be x equal to minus AE. Do you realize this line L? This line L, which is x equal to minus AE, will be the directrix of the parabola. This must be the directrix of the parabola. Clear? Now, the ordinate of the point from which the pair of tangents drawn to both the parabola and the ellipse are separately at right angles. We want to find the y coordinate of that point. We want to be able to find the y coordinate of the point from which the two tangents drawn to the parabola are perpendicular and the two tangents drawn to the ellipse are also perpendicular. Absolutely. Intersection of the director circle and the directrix. Because if you want perpendicular tangents to the parabola, then that point must lie on the directrix. And if you want perpendicular tangents to the ellipse, then that point must lie on the director circle of the ellipse. So what we are seeking is a point. We are seeking a point which lies on the director circle of the ellipse and also lies on the directrix of the parabola. That means we are seeking the intersection of the directrix of the ellipse, which is x equal to minus AE, with the director circle of the ellipse. This is the directrix of the parabola, and the director circle of the ellipse is x squared plus y squared is a squared plus b squared, which is a squared into 1 minus e squared. Right? Intersection of these two will give me the required point. So the x coordinate of that point will obviously be minus e. So plug in x equal to minus AE. And solve for y square. Solve for y square. Yes or no? Right? The y obtained out of this will be the y coordinate of the required point. It will lie on the directrix of the parabola, and the two tangents drawn from that point to both the parabola and the ellipse would be perpendicular to each other. Yes or no? X squared plus y squared is a squared plus b squared. That's the director circle of the ellipse. The directrix is the director circle of the parabola. Intersection of these two, put x equal to minus AE whole squared and solve for y squared. Got me? Okay. Can I wipe this off? Now, pair of tangents are drawn from any point on L equal to 0 to S1 equal to 0 and S2 equal to 0. S2 equal to 0 is the parabola, right? Pairs of tangents are drawn from the directrix, right? I select a point on the directrix. I select a point P on the, let's say A on the directrix, call it minus AE, comma, Y. Minus AE, comma, Y. Or let me call it Y naught. Let me call it Y naught. Let me call it Y naught. Minus AE, comma, Y naught. Alright. Y naught is a parameter here. Y naught is a parameter here. Different values of Y naught will give you different A's on the directrix. So Y naught is a parameter which would eventually require elimination, right? So that the condition would be true for all A's that lie on the directrix. Got me? Now, from such a variable point, pairs of tangents are drawn to the ellipse, pairs of tangents are drawn to the parabola. So for each such position, there is going to be a chord of contact of the ellipse, there is going to be a chord of contact of the parabola. And therefore, each time you select A, there are two chords of contact, and the two chords of contact will intersect at a point. If you select another A, that means another Y naught, you get another point of intersection of the chord of contact. We are seeking to find the locus of the point of intersection of these chords of contact. Yes or no? Now, the chord of contact for the ellipse. Chord of contact. T equal to 0. For this ellipse, x(x1) by a squared plus y(y1) by b squared minus 1 equal to 0. Right? So, chord of contact of the ellipse with respect to a would be x(x1) by a squared plus y(y1). y1 is y naught, which is a variable. E squared equal to 1, t equal to 0. That's the chord of contact with respect to a of the ellipse. For the parabola, y(y1) is 2ae into x plus x1, isn't it? T equal to 0, y(y1) is 2a into x plus x1, that kind of a thing. So, y(y1) means y into y naught equals 2ae into x plus x naught. X naught is minus ae. So, yes or no? Now, what is it that we are trying to do here? We are trying to find the point of intersection of the chord of contact. Locus of the point of, now in this case, see, what you can do is y naught that you have obtained here, plug into this and solve for x. Have you done that? How much does it turn out to be? A by E. So if this y naught equal to this is plugged into this, and if you solve for x, then as Sumek suggests, x turns out to be A by E, which is different points on the directrix of the ellipse. Right? So y naught is 2a into x minus x naught plugged into this will give me x equal to A by E, which you can check independently. So that's the point of intersection of the various chords of contact. The various chords of contact have their locus as the directrix of the ellipse, which is what happens here. Right? Okay. So far so good, right? Let's look at the next part of this comprehension. Can I remove the clutter from you? You'll be able to solve this, right? Plugging in y naught and you can solve for x very easily. Huh? Now, if the tangent at a point q on S1 equal to 0 and the line joining P to the focus of S1 equal to 0 intersected the auxiliary circle of S1 equal to 0. Of course, once again, this is S1 equal to 0. Say remove this. I don't need this anymore. Right? Say I draw a tangent at a certain point Q. Okay. Right. At a certain point Q, which is theta, eccentric angle theta, that means A cos theta, B sin theta. What would be the equation of the tangent at Q? Tangent at Q, x cos theta by A plus y sin theta by B equal to 1. Now, what they say is, if P is joined to F1, if P is joined to F1, if P is joined to F1, then this point is known to be lying on the the auxiliary circle of the ellipse. This point M, they say M lies on the auxiliary circle. Ellipse. M lies on the auxiliary circle of the ellipse. Now, if you recall a result, the perpendicular drawn from the focus onto any given tangent, the foot of that perpendicular always lies on the auxiliary circle. The foot of the perpendicular from the focus onto any given tangent lies on the auxiliary circle. Now, M is known to lie on the auxiliary circle. So, M must be the foot of the perpendicular from F onto this tangent. Yes or no? If M lies on the auxiliary circle, M must be the foot of the perpendicular drawn from the focus onto this tangent. That means this must be 90 degrees. Yes or no? If this is 90 degrees, that means the slope of this into slope of this must be -1. Yes or no? What is the slope of the tangent? The slope of the tangent, as you minus b by a cot theta is the slope of the tangent, slope of this line. Now P has x coordinate a by e. It is also a point on the parabola, if you recall. The parabola passed through this point, right? So if you plug in x equal to a by e, y becomes 2a in the first quadrant. Y becomes 2a, put x equal to a by e, because this was, recall the earlier figure. If you plug in x equal to a by e, y becomes 2a, right? So if x is a by e, y is 2a, right? Which means PF1 perpendicular to this, the slope of PF1 into slope of the tangent must be -1, right? This would enable computation of the eccentric angle of Q. So 2a minus 0 divided by a by e minus ae. 2a minus 0 by a by e minus ae, that's the slope of this line, into minus b by a cot theta, which is the slope of the tangent. That must be -1, right? So, see, b by a is root 1 minus e squared, isn't it? B by a is root 1 minus e squared. And this is like 2e by 1 minus e squared. And that must be into root 1 minus e squared that must be tan theta, cot theta taken on the other side. This will be tan theta, and b by a written as root 1 minus e squared. This e goes up, a gets cancelled, so 2e by 1 minus e squared, this must be tan theta. So tan theta then giving us the eccentric angle 2e by root 1 minus e squared. Such must be the eccentric angle theta of the point. Got me? All's fair? Can I wipe this off? Some of the results which you would have forgotten, you know, they would automatically come back to you in an emergency situation where you never get to revise ellipse back at home. You know, there would be some residual remains of whatever I cover in the class. Never know, it could just be handy. Okay, examine comprehension 3. There is, of course, all of you understand, a second degree equation is 0 will represent an ellipse if two conditions are met. That generalized discriminant, which is that determinant a, b, c, etc., that should not be 0, and h square must be less than ab. H square must be less than AB, that's when it's going to represent an ellipse. All right. Now, number 6. X square plus lambda xy plus y squared minus 1 equal to 0. We wanted to represent an ellipse. We wanted to represent an ellipse. The integral values of lambda for which this will represent an ellipse, the integral values of lambda for which this would represent an ellipse would be, see in this case h is lambda by 2, so lambda by 2 whole squared less than a is 1, b is 1, so 1. Come in, hop in. You have the sheet with you? Okay, come. Such must be lambda for it to represent an ellipse. So lambda squared must be less than 4, lambda must be less than 2 and greater than minus 2. So the integral values of lambda must be minus 1, 0, 1. These are the integral values of lambda then. 3 integral values of lambda. Therefore, only 3 integral values of lambda for which this could happen. Right? Lost? No? So n integral values means n must be 3. Now, the next part of the comprehension, problem 7. The length of the longest chord of the ellipse. Of course, this is an inclined ellipse. This is the ellipse, right? Which has its equation as x square plus y squared plus lambda xy minus 1 is 0, right? Oh, lambda is 1, lambda is 1, okay, plus xy minus 1 equal to 0. We want to find the length of the largest chord of the ellipse, means the major axis. So this will give you an opportunity as to how to find the major axis of the ellipse, right? So realize, if there is a generalized thing, whatever I do here will suggest to you that given the generalized equation of an ellipse, how to find the major axis, how to find the minor axis, and whatever I do here will work for all generalized situations. Okay. Now, in all these cases, what you do is, see, this expression is f. The first thing that you should do is find the center of the conic. Dou f dou x is 0, dou f dou y equal to 0 will give me the center of the conic. See the center of the conic. Conic. Dou f dou x, which is like 2x plus y, that must be 0. Dou f dou y, which is 2y plus x must be 0. So if you solve this, you get x equal to y equal to 0, the center of the conic. You get x equal to y equal to 0, the center of the conic, yes or no? So the center of the conic is 0, 0. Now, say this is the x-axis. Say this is the x-axis. Now, any point P on the conic section can be located with the help of a r and a theta. R and a theta. R and a theta. The largest r will give me the major axis. The smallest r will give me the, in fact, largest r will give me the semi-major axis because it's distance from the center. The smallest r will give me the semi-minor axis because these are distances from the center, right? Now, if this be the case, do you realize that the x coordinate of P will be r cos theta, y x coordinate would be r cos theta, y coordinate would be r sin theta. So P must have coordinates r cos theta and r sin theta. Right? The equation of the conic was x square plus y square plus xy minus 1 equal to 0. Right? The equation of the conic was x square plus y squared plus xy equal to 1. That was the equation of this conic. Now r cos theta, r sin theta. Theta is not the eccentric angle of this point. Eccentric angle is with respect to the auxiliary circle. So this is not the eccentric angle. This is actually the polar angle. Right? Very good. Polar angle. So r cos theta, r sin theta, right? These are the coordinates. They must satisfy this equation, right? Put x is r cos theta, y is r sin theta. For different thetas on the ellipse will satisfy this condition, right? So r cos theta whole squared plus r sin theta whole squared would be r squared, this square plus this squared, plus r squared sin theta cos theta. That must be 1. R square I have taken common. So sin theta cos theta must be 1. So r squared must be 1 by 1 plus half sin 2 theta. Yes or no? R square will be minimum when sin 2 theta is minus 1. When sin 2 theta is minus 1, this will have the smallest value and r square will have the maximum value, right? For r to be r max, r will be r max if the denominator is the smallest. That means sin 2 theta is minus 1. If sin 2 theta is minus 1, that means the required r squared max can be obtained from this equation. Plugging in sin 2 theta is minus 1. So 1 minus half. So that makes it 2. So r max is root 2. So this must be the semi-major axis of the ellipse. So the major axis of the ellipse is going to be 2 root 2. The major axis of the ellipse is going to be 2 root 2. And that's going to be the longest chord of the ellipse. That's going to be the longest chord of the ellipse. Yes or no? Now r will be r min. R will be r min if sin 2 theta is maximum. That means 3 by 2, isn't it? This will be 2 by 3 if sin 2 theta is plus 1, and r min squared is 2 by 3 then, or r min will be root 2 by 3, and twice r min will be the minor axis, twice r min. So the minor axis of the ellipse is going to be twice r min. Got it? Okay, let's look at the next one. So the next one is Armin only. Okay, let's look at comprehension 4. Comprehension 4. There is an ellipse. This is the major axis of the ellipse. The ellipse is x squared by a squared plus y squared by b squared equal to 1. That's a ellipse centered at O, having AB and CD as its major and minor axis. AB is the major axis, CD is the minor axis. If S1 be one of the foci of the ellipse, S1 is one of the foci of the ellipse, the radius of the inner circle of triangle OS1. See, this is the triangle OCS1. The in radius of this triangle, is given to be 1 unit. OS1 is given to be 6 units. Okay, we want to find the area of the ellipse. The area of the ellipse is pi AB. So we need to find A and B essentially. Now, this of course would be B, the semi-minor axis of the ellipse. And what will this be? No, not from those considerations. In terms of, it will be A. Do you realize that? Semi-major axis of the ellipse. Why? Okay. See, this is a point on the y-axis. This distance is A by E. The distance of this directrix, x equal to A by E. And the distance from this point will be E times distance from this point. That's a property of the ellipse, isn't it? This will be E times this. Yes or no? Yes, SP is E times PM1. Right? This distance from the focus would be E times the distance of from the directrix for any point on the ellipse. And this distance is A by E. Right? So E times that's going to be A. Okay. Now, this 6 must be AE. 6 must be AE. Yes or no? AE must be 6. Distance between the center and the focus is semi-major axis into eccentricity of the ellipse. Also, realize the in radius of the triangle is given by, if you, recall my class on properties of triangles. The in radius of a triangle is area of the triangle divided by its semi-perimeter. Huh? Right? Delta by S? Delta is half of B into 6, the area of the triangle, half of B into 6, divided by the semi-perimeter, which is A plus B plus 6. And that's given to be 1. This gives me A plus B plus 6 is 3B. Yes or no? Sorry, by 2. So that will be 6B. Semi-perimeter by 2, 6B. So A minus 5B equal to minus 6. One equation. And Pythagoras theorem, A square is B square plus 36. Forgot? Okay. A square is B square plus 36. What do? Solve for A and B from these two equations, right? You can write A as 5B minus 6. Right? A as 5B minus 6. You can plug into this and solve for B. Right? If you solve for B from this, if B is known, then obviously A is also known. A will be 5B minus 6, so A and B will be known. The eccentricity of the ellipse would be known, so A is known, B is known. The eccentricity of the ellipse would be known. 1 minus B square by A squared. The area of the ellipse is going to be pi AB. That's going to be the area of the ellipse. Whatever the values turn out to be. Once you know B and A, then the perimeter of the triangle is going to be B plus 6 by plus A by 2, OCS1. So which is not an issue, right? SB, the director circle of the ellipse. The director circle of the ellipse is what? X square plus Y squared is A square plus B squared. Whatever A and B turn out to be, I'm not doing those calculations. That's a director circle of the ellipse. That's a director circle. We want to find the director circle of this director circle. If I have a circle x square plus y squared is r squared, is say L squared, then the director circle of this would be x square plus y squared is 2L squared. Right. So the director circle of this circle is going to be x square plus y squared equal to 2a square plus b squared would be the director circle, where a and b have been found from these considerations. This is the director circle of the ellipse, and the director circle of this circle will be x square plus y squared is 2r squared. So I will leave the computation to you. We'll be wasting time in the class, so you can do solve for a and b. All right. Let's look at comprehension 5. Can I wipe this off? Hey, one thing. I don't have to appear for an exam, so I can leave computations undone. You don't do that, because no one else will do it for you. Huh? Okay, she's done that. That's nice. A is 13 by 2 and B is 5 by 2. All right. Very good. Excellent. This is what you got? You did something else? Okay. Comprehension 5 now. There is an ellipse. This is an ellipse with its center C13, center C 1, 3 and focus S 6, 3. Very clearly, the major axis of the ellipse is y equal to 3, as you can see from inspection. Y equal to 3 is the major axis of the ellipse, isn't it? Huh? Dekho, y is 3. So y equal to 3 is the equation of the major axis of the ellipse. And the ellipse passes through a point 4, 7. ellipse passes through a point P 4, 7. The product of the lengths of the perpendicular segments from the two foci onto the tangent at P, that will be square of the semi-minor axis. So eventually we need to find A and B, right? Now this length is 5 units, as you can see. That means the other focus S prime would be minus 4, 3. That will be the other focus S prime. 5 units and 5 units. Now, yes, very good, excellent. So, the major axis is SP plus S prime P will be 2A, the major axis of the ellipse, yes or no? Right? So, 2A, the major axis of the ellipse, is SP plus S prime P. So, which is like 64 plus 16 root 80 plus 4 plus 16 root 20, right, which is, this is 2 root 20 plus, so this is 3 root 20, which is 6 root 5, which is 6 root 5 is 2A. So A therefore must be 3 root 5. Also, distance between the center and the focus is AE. Right? AE must be 5. AE is 5. Now, what is AE? AE is 5. A we have known, so I can find E from here. So E therefore would be 5 by 3 root 5. So which is root 5 by 3 is the eccentricity of this ellipse. B. So B squared is A squared. A squared, which is 45 into 1 minus E squared, which is 5 by 9. Right? So which is 45 into 4 by 9, which is 20. B squared is 20. B squared is 20 for the ellipse, right? So the product of the perpendiculars will be B squared, square of the semi-minor axis, which will be 20. Option A. The product of the perpendiculars from the two foci onto any given tangent would be square of the semi-minor axis, and in this case it turns out to be B squared. Now, so let me just write separately so that I can remove the clutter from here. B squared turns out to be 20. A squared turns out to be 45. E turns out to be root 5 by 3. Right? Let me now remove this data from here. I'm done with this data. Right? By the way then, if you have to now find the equation of the ellipse, what would be the equation of the ellipse? X minus 1 whole squared by A squared, which is 45, plus y minus 3 whole squared by B squared, which is 20. That must be 1. That's the equation of the ellipse. Got me? Now, the next part of the problem is the point of intersection of the lines joining each focus to the foot of the perpendicular from the other focus upon the tangent at P. So, at P I draw a tangent. At P I draw a tangent. And say this is one focus S, and the foot of the perpendicular is this. Say F1 is the foot of the perpendicular. F2, the foot of the other perpendicular from the focus S prime is this. What we need to do is, I join S prime to F1, I join S to F2. I want to find the coordinates of this point. I want to find the coordinates of this point. This actually will bring me to a very important property of the ellipse. My claim is, and then I'll justify that, it's a property you might have just forgotten. If I draw a normal at P, if this is a normal at P, if this is a normal at P, and this normal intersects the axis at G, if this normal intersects the axis at G, then this point M will be the midpoint of PG. I claim that M will be the midpoint of PG, and I'll establish that for you in a little while. It's a standard property. It's a standard property. From, if you draw a tangent and you join each focus to the foot of the perpendicular from the other focus, then the two intersect on the normal drawn at P, and that point would be the midpoint of PG. Let me give you a formal proof for this. It's not difficult. Have you noted down the property before I establish it for you? So essentially, I'll have to draw the normal at P, and the midpoint of PG will be that required point M. That means PF1 will bisect PG. PF1 will bisect PG. I'm sorry, S prime F1 will bisect PG. SF2 will bisect PG. Let's see. Can I remove this for a while? And henceforth, recall this property. It will come useful once in a while. See, this is the ellipse. This is the tangent drawn at a certain point P of the ellipse. Tangent drawn at a certain point P of the ellipse. There is this focus S. There is this focus S. Think of this tangent as a mirror. Think of this tangent as a mirror. Now, this would be the object distance. SF1 will be the object distance. SF1 will be the object distance, yes or no? If this is the mirror, then the image of S will be this, say SI, will be the image of this. Object distance equal to image distance. That means F1 must be the midpoint of SSI. SI is the image of S. SI is the image of S. Plane mirror, object distance is image distance. Right? Now, that means if this is an incident ray starting from S and hitting the mirror at P, then after reflection it must look like coming from the image? Yes or no? After reflection it must look like coming from the image SI? Right? It look like as if it's coming from the image SI. That's the definition of an image. Right? The reflected rays either converge or appear to diverge from the image. Right? So it seems like coming from SI. But if there is a ray of light incident on the mirror, then starting from the focus, after reflection it must pass through the other focus, S prime. Right? Now, this is the point of incidence P. This is the point of incidence P. This will be the normal at the point of incidence. Normal at P. This is the normal at P. Yes or no? This is the normal at P. Now, look at this triangle. S, Si, S prime. This is P. By the way, SSI and PG will be parallel to each other, isn't it? Because both are perpendicular to the tangent. SSI is perpendicular to the mirror and PG is also perpendicular. So PG will be parallel to SSI. This is PG, which is parallel to SSI. PG is parallel to SSI, right? F1 is the midpoint of SSI. F1 is the midpoint of SSI, yes or no? And this is parallel to SSI, which means if I join S to F1, then if this bisects this, it will bisect all lines parallel to this. That means this point M must be the midpoint of PG, isn't it? Yes or no? If this bisects this line, it will bisect all lines parallel to this line. So PG will be bisected at M, yes or no? So what is F1? F1 is the foot of the perpendicular from this focus onto this tangent. And if you draw a line from the other focus onto the foot of the perpendicular from the first focus, it will bisect PG. It will bisect PG. M will be the midpoint of PG. Yes or no? Right? That means that establishes the proposition. That means both those S prime F1 and S F2 that we draw, both will pass through M. They intersect at PG. They intersect PG at the midpoint of PG. Right? Got me? Remember this result. Now, of course, it's very ordinary algebra. If you get a hang of this result, can I wipe this off? Similar triangles here. Just similar triangles. This by this must be equal to this by this. Yes or no? But this is equal to this, so this must be equal to this. Sounds all right? I hope you quite understand this, right? Because this by this, for this triangle must be this by this. And for this triangle, this by this must be equal to same thing, this by this. Exactly. Clear? Okay, so now of course the job is easy. All that I need to do is find the normal at P and find its intersection with the line y equal to 3. So that would be G, and I would know P, and the midpoint of PG will be M, the required point, right? And how do I find the normal at P for this? Okay, let me differentiate this. Let me find the slope of the normal at P. So when I differentiate this, I get 2 into x minus 1 by 45 plus 2 into y minus 3 by 20 into dy dx equal to 0. That's the slope of, this will give me slope of the tangent. Yes or no? Dy dx, therefore, slope of the tangent at any xy for this general ellipse is going to be minus x minus 1 by y minus 3 into 20 by 45 minus of x minus 1 by y minus 3 into 4 by 9. That's the slope of the tangent at any point. So if I have to find the slope of this tangent, put x equal to 4 and y equal to 7 in this. Put x equal to 4 and y equal to 7, I'll get the slope of the tangent here. So put x equal to 4 and y equal to 7. So 4 will get cancelled, 3. So minus 1 by 3, is it? Just check. 4, 3, 3. Minus 1 by 3 is the slope of the tangent, if I have not made a mistake. So that means the slope of the normal at P would be what? 3? Slope of the normal at P. Slope of the normal at P would be 3. P is 4 comma 7. And so I can find the equation of the normal at P. Y minus 7 is 3 into x minus 4. To find the intersection with the line y equal to 3, plug in y equal to 3 here and solve for x, you get g, isn't it? Put y equal to 3 and solve for x, you get g. And once you know g, then x1 plus x2 by 2, y1 plus y2 by 2, that will be the midpoint of PG, the required point. Yes or no? So this is the equation of the normal. To find g, put y equal to 3. So for g, y is 3 because it's a point on the line y equal to 3. Y equal to 3 and so on and so forth. X is known from these considerations. Okay, just show. Okay. Match with the options. Okay. Okay. Now, whatever this turns out to be, but you must obtain the final answer. Don't leave it half baked. Huh? Now, the part 14. It's a property, standard property. I must have mentioned this property at some point of time, right? So if these are the major and the minor axis, this is the major axis, this is the minor axis, it need not be x and the y axis, this is just the major axis. And this is the minor axis, need not be the x and the y axis, could be anything. The physicality does not change. And meets the axis. So if I draw a normal at P, this is a normal at P, this is a normal at P, and it intersects the axis in Q and R. Q and R. And is the then the locus of the midpoint of QR. See, this is again a standard property. If you draw different normals, that means normals at different points, you will get different QRs, right? What we want to find is the locus of the midpoint of QR. So you get different Qs and different Rs for different Ps, different normals. The property that you must remember is the midpoint of QR will have a trajectory which is an ellipse having the same eccentricity as that of the mother ellipse. The locus of M will be an ellipse. The locus of M, the midpoint of QR, the locus of M, just note down if you've forgotten, the locus of M, the midpoint of QR, the locus of M, the midpoint of QR will be an ellipse, having the same eccentricity, as the mother ellipse, The locus of M will be an ellipse enjoying the same eccentricity as that of the mother ellipse. What was the eccentricity of the mother ellipse? Root 5 by 3. So the locus of M will be an ellipse with eccentricity root 5 by 3. Property to be remembered. This is a property to be remembered. Now, comprehension 6. A half 0, B 3 by 2 0, C 5 by 2 0. Okay, they are all points on the x-axis, right? A half 0, say B 3 by 2 0, C 5 by 2 0. Be given points and P be a point. So these are fixed points on the x-axis, right? And it's given P is a point, moving point. P is a moving point. Satisfying maximum of PA plus BP and PB plus PC less than 2. Satisfying this condition, maximum of the larger of PA plus PB or PB plus PC does not exceed 2 units. Okay. But that means, can I not say that P is such that PA plus PB must be less than 2 and PB plus PC must be less than 2. Can I say this? Right? If the larger does not exceed 2, then each one of them will be less than 2. Such must be P. Now, PA plus PB equal to 2 is an ellipse whose foci are A and B. PA plus PB equal to 2 is an ellipse whose foci are A and B. PB plus PC equal to 2 is an ellipse whose foci are B and C. So let me, and all points inside one ellipse would be PA plus PB less than 2. All points inside the other ellipse would be PB plus BC less than 2. Yes or no? Right? So one ellipse is like this. This is, say, PA plus PB equal to 2. Equal to 2. All P's on the ellipse would be PA plus PB equal to 2. All points inside the ellipse, would be PA plus PB less than 2. Right? Yes or no? Now, the other one, PB plus PC less than 2, are P's inside an ellipse with foci B and C, isn't it? In this case, these are points P inside an ellipse whose foci are B and C. Maybe symmetry. Badly drawn, but you can draw it a little better. When you have to draw it over a large space, then you go disproportionate. Okay. So all points inside this ellipse would be PA plus PB less than 2. All points inside this ellipse would be PB plus PC less than 2. So two ellipses, one with foci A and B. This is an ellipse with foci B and C. Clear? So this region is the region governed by this condition, right? Now let's look at the problem. One thing, for this ellipse, for example, this ellipse has 2A equal to 2, isn't it? A equal to 1 for this ellipse. Same with this ellipse, because the semi-major axis of this ellipse is also 2. A is 1 for both ellipses, right? Now do you realize distance between A and B is 2AE? This distance is 3 minus 1, 2, 1 half. Half is this distance? 2, 1 half. Same distance. So 2AE is the same for both. So B must be the same for both. So E must be the same for both ellipses. Both ellipses are of the same eccentricity, same major, same minor axis. Their centers are different. Yes or no? So 2AE is 1, right? 2A is 2, so E is half. B squared is A squared, which is 1 into 1 minus 1 by 4, which is 3 by 4. So B is root 3 by 2. B is root 3 by 2 for both ellipses. A is 1 for both ellipses. B is root 3 by 2 for both ellipses. Right? Now, let me so 15. All points P are common to two ellipses, right? The locus of P is symmetric about the x-axis. The locus of P is symmetric about the x-axis, right? The area of the region P do you realize is this region? Is this region? That's a region? Yes or no? This is the required region for this condition, isn't it? Both these have to be, right? This is the region because both PA plus PB and PB plus PC have to be less than 2. If I select this region, then PB plus PC will become larger than 2. If I select this region, then PA plus PB will become larger than 2. But if I select this region, it belongs to both ellipses. So PA plus PB will be less than 2. PB plus PC will also be less than 2. This is the region. And this region, as you can see, enjoys symmetry about the x-axis. Right? This is the region. And we want to find the area of this region. Not a difficult task. Not a difficult task. Integration is involved, obviously. Integration is involved. You can find, let's say, equation of one of the ellipses. The center of this ellipse is what? 8. How much? 2, 0 is the center of this ellipse. So the equation of this ellipse is going to be x minus 2 whole squared by a squared. A squared is 1 plus y minus 0 whole squared by b squared. B squared is 3 by 4. That must be 1. That's the equation of this ellipse. Right? And from symmetry again, you can see that 4 times this area will be the required area. 4 times this area will be the required area. Right? This plus this plus this plus this is actually 4 times this area from symmetry considerations. Right? Now, you can find the coordinates of this point. So all that you need to do is select strips of this kind for this ellipse, y dx, and this point, let's say, is q. 1, 0 is this point. This point is 1, 0, right? And therefore, y dx, all that you need to do is, of course, integration is required here. Integral this strip is y dx. X runs from 1 to 3 by 2. X runs from 1 to 3 by 2 into 4. That will be where y you can obtain some root 1 minus etc. this squared. You will have to integrate this. Clear? All's good so far? Number 18. There is an ellipse x square by 25 plus y square by 16 equal to 1. There is the y-axis and the x-axis. A tangent at any point P, x1, y1, meets the line x equal to 0 means the y-axis at Q. Q, let's say, has coordinates 0, comma a. Q has coordinates 0, comma a, right? R be the image of Q about the line y equal to x. So, if Q is the point 0, comma a, then its mirror image, right, about the line y equal to x is a comma 0. Would be a comma 0, right? A circle is drawn with diameter QR. A circle is drawn with diameter QR. Very clearly, this then would be an angle in a semicircle, 90 degrees, right? That means that circle will necessarily pass through O. That circle will necessarily pass through O. If this is the diameter, then this must be angle in the semicircle because it is 90 degrees. So that circle will always pass through 0, 0. So for various tangents, you have various Q's and various R's, but the circles drawn with diameter QR will always pass through the origin O. So that's the fixed point that we are talking of. It passes through that fixed point. Clear? So number 19. There is an ellipse x square by 50, y square by 20 equal to 1, and there is another ellipse x square by 16 plus y squared by 9 equal to 1 is another ellipse. The number of points on this ellipse from which pairs of perpendicular tangents drawn to this ellipse. Now, obviously, if we want perpendicular tangents to this ellipse, then those points must lie on the director circle of this ellipse. The director circle of this ellipse is x square plus y squared is 25, 16 plus 9, right? For perpendicular tangents to this ellipse, though xy's must lie on the director circle of this ellipse, which is x square plus y squared is a square plus b squared. Now, what about this ellipse? This ellipse is x square by 50 that means in this ellipse, a square is root 50, which is 5 root 2, a is therefore 5 root 2. The major axis of the semi-major axis of the ellipse, and b is 2 root 5. That means this is 2 root 5 and this is 5 root 2 for this ellipse. Now, this circle x square plus y squared equal to 25, would you realize if you draw, will be, see, radius of this is 5, which is more than this, but less than this, right? And therefore, if that be the condition, this would be a rough look of the circle with respect to this ellipse, right? So that the radius of the circle becomes less than 5 root 2, but greater than 2 root 5, center O, right? So then, on this ellipse, the points that lie on the director circle are 4. 4 points on this ellipse lie on the director circle of this ellipse. 4 points on this ellipse, lie on the director circle of the second ellipse. That means from each of these points A, B, C and D, I could have drawn perpendicular tangents to this ellipse, because these are points on the director circle of the second ellipse. Sounds good? Bless you. So there is an ellipse that is drawn with, this is an ellipse which is drawn with major axis 2a equal to 10 and 2b equal to 8. So a is 5 and b is 4, right? So e squared is 1 minus 16 by 25. E must be 3 by 5, right? Now, this is the major axis of the ellipse. Using one focus as center, a circle is drawn that is tangent to the ellipse, with no part of the circle being outside the ellipse. Right? Using one focus, so this is the center, C, this is the other focus, S. Now, CS would always be A into E. CS is always A into E. A is 5 and E is 3. So this is 3 units. CS is 3 units. And this is the other extremity. CA would be the major axis of the ellipse, which is 5 units. 2A is 10. So A is 5. So this is 5. Now with S as the center, a circle is drawn. A circle is drawn which is tangent to the ellipse. A circle is drawn which is tangent to the ellipse. That means it has a common normal with the ellipse. What would be the radius of the other circle? Now, obviously, yes. I'll just draw an extended view of this part. Otherwise, this would be the focus S. Very clearly, you know. This would be the formation of the other circle. This would be the formation of the other circle. Right? This is this part of the ellipse. And SA, as you can see, is 2 units. So the radius of the circle is 2 units. Radius of the circle is 2 units. You have a question, I think. Okay, I know your question, and I'll tell you what. So, you would want to get a little cynical and ask this question. Why would you not believe that if this is the ellipse, I could have drawn a circle like this? Why would you not believe that I could have drawn a circle like this? Why did I force a circle this way? Why can't I draw a circle whose focus is S and be like this? That's the question. Am I right? Okay. No, that's all right. This or that, both will have the same answer. Okay. Now, first of all, it couldn't have gone out because, they must be, with S as the focus, if it is tangent, it has to be impartial to the upper and the lower half. So, if there is a point of tangency here, there has to be a point of tangency there also. Okay, now that will also be addressed, don't worry. One thing, and think about it, S prime. If the circle and the tangent, circle and the ellipse touch each other, they have a common normal, right? And that common normal must pass through the focus. That common normal must pass through the focus. If this was the common normal, for example, it has to pass through the focus, because if it is normal to the circle, for sure it has to pass through the focus. And since the two are touching each other, it must also be a normal to the ellipse. Now, suppose this was the case. This point is P. Instead of A, say it was P. This will have also include the answer to your question. Think about it. Now, if a ray of light, if this was the case, and if there was a ray of light starting from S and going to P, then what is the angle of incidence? 0. So, angle of reflection must be 0. That means it will get reflected along the same path. Then it will not pass through the other focus. Which cannot happen, right? Bless you. If a ray of light starting from one focus is incident on the ellipse, then after reflection it has to pass through the other focus. But in this case, it has to pass through the other focus. See, after reflection, it will pass through the other focus. Angle of incidence 0, angle of reflection 0, and in order to pass through the other focus, it has to be like this. So that cannot be the case. And all other distances would have to be less than the radius. Think about it. Got it? Okay. Right. They can't be the same also. If the focus is set. A circle has the same center as an ellipse and passes through the foci F1 and F2 of the ellipse. Center of the circle and the center of the ellipse, the same. And the circle passes through the two foci. With C as the center, the circle is known to pass through the two foci. This is F1, one focus. This is F2, the other focus. PB, so there are 4 points, 1, 2, 3, 4. PB, one of the points of intersection of the circle with the ellipse. If the major axis of the ellipse is 17, and the area of the triangle PF1, F2 is 30. It's given that the major axis is 60, right? Is 17. Is 17. Major axis is 17. That means PF1 plus PF2, right? That's the major axis, 17. That's the major axis. And the area of this triangle, half of PF1 into PF2. Half of PF1 into PF2, the area of this triangle is given to be 30. So, PF1 into PF2 is 60. Right? So, obviously PF1 and PF2 are roots of x squared minus sum of the roots into x plus 60 equal to 0. Isn't it? They are the roots of this PF1 and x square minus sum of the roots 17 into x plus product of the roots 60 equal to 0. PF1, PF2 must be the roots of this. So x minus 12 into x minus 5 must be 0. X is, so one of them must be 12, the other one must be 5. Any one of them could be 12, the other one would be 5. So PF1, this for example is 12, then this will be 5. And by the way, this is 90 degrees. Why? Because this is a diameter. That's why I could take this. So the distance between the two foci therefore would be 13, isn't it? 12 squared plus 5 squared is 13 squared. So this is 13. Right? And the distance, so this is what? Distance between the two foci is 13. And so this is also 2AE. 2AE is 13. 2A is known, so eccentricity of the ellipse is also known. And if E is known, A is known, then B squared is A squared into 1 minus E squared is also known. Is that all right? So there is an ellipse which is x squared by 25 plus y squared by 9 equal to 1 is an ellipse. This is the auxiliary circle. The auxiliary circle would be x squared plus y squared equal to 25. That will be the auxiliary circle. X squared plus y squared is a squared. That's the auxiliary circle. Now this is a certain ordinate MP of the ellipse, and it intersects the auxiliary circle at Q. This is the center C, which is 0, 0. So for different ordinates, you'll have different Q's. We need to find, and each time you draw this ordinate, you can draw a normal at Q and the normal at P. We need to find the locus of the intersections of the normals at P and Q. That is what we need to be doing. Right? Now, what is Q? Q is a point on the circle x squared plus y squared equal to 25. So suppose the polar angle of Q is theta, then the eccentric angle of P will be theta. Right? So if Q is 5 cos theta, 5 sin theta, then P will be what? 5 cos theta, 3 sin theta. A cos theta, B sin theta. That will be P. Right? Now, what would be the equation of the normal at P? This is a line passing through the origin, and the slope of this line is tan theta, isn't it? 5 sin theta minus 0 by 5 cos theta minus 0. It's a line passing through the origin. So that's equal to y equal to x tan theta. Equation of the normal at P. Right? Equation of the normal at Q. Sorry, Q, normal at Q. Y equal to x tan theta. Now, normal at P is ax sec theta minus by cosec theta is a squared minus b squared. Right? Ax cos theta means 5x cos theta minus by, which is 3y sin theta, is is 25 minus 9, 16. That's the equation of the normal at this. Theta is different for different Q's. So I need to eliminate theta between 1 and 2. I need to eliminate theta and find a relationship that will between x and y that will satisfy this as well as this. That will be the point of intersection of these two normals. An xy that satisfies this and an xy that satisfies this. Right. So what I could do here is, see, in this case, I could have written this as x sec theta, x by cos theta, ax sec theta minus by cosec theta. I'm so sorry, please fix this. Ax sec theta minus by cosec theta is a squared minus b squared. Now, from this, I get x sec theta is y cosec theta, right? That means like x by cos theta is y by sine theta. Each will be equal to root x square plus y squared. Yes or no? Do you realize why? Huh? Because each will be square root of sum of the squares of the numerator, sum of the squares of the denominator. So x sec theta is root x square plus y squared. So 5 into root x square plus y squared minus 3 y cosec theta. Y cosec theta is also root x square plus y squared. That's equal to 16. So 2 root x square plus y squared is 16. So root x square plus y squared is 8, or x square plus y squared is 64. Yes or no? So this gives me x square plus y squared equal to 64. The intersection, locus of the intersection of the two normals. Yes or no? Right? So number 23. There is an ellipse, x squared by 169 plus y squared by 25 equal to 1 is an ellipse. There is a point P which is 0, 6 on this ellipse. And we are drawing normals. We are supposed to be drawing normals to this ellipse from this point. We want to find out the number of distinct normals that could be drawn to the ellipse. One, of course, is this normal, which is the minor axis, right? We need to find out the other normals. What are the other normals? See, let's say the other normal is at theta. Then the normal is going to be ax sec theta. A is 13 x sec theta minus b, which is 5 y cosec theta, is 169 minus 25, 144. That's the normal at any theta. Now, but we are seeking only those thetas for which the normal passes through 0, 6. 0, 6 must lie on this normal. So put x equal to 0 and y equal to 6. Put x equal to 0 and y equal to 6. So 0, 6 will lie on this normal. So x equal to 0, y equal to 6 will give me cosec theta equal to minus 144 divided by 30, which is a negative number. That means theta would lie in the third and the fourth quadrant. Theta will lie in the third and the fourth quadrant. Yes or no? Yes. So in all, how many normals? 3 normals. See, suppose this cosec theta turned out to be a number numerically less than 1 for a certain point. Suppose I select this point in a manner, could I have not selected x equal to 0 and y equal to, let's say, a very large number? Say if I selected y a very large number, then cosec theta will turn out to be a very small number numerically. Say very far away on this y-axis, cosec theta will turn out to be numerically less than 1, which is not possible. Suggesting what? That the other normals don't exist. So it's not by visual inspection. The numbers will be important, right? Only those y's. So now you can conclude up to what y on the y-axis will you have the other two normals real? Such cosec theta equal to minus 144 by 5 should be less than or should be greater than or equal to, numerically greater than or equal to 1 for you to be able to obtain real normals, right? So the cosec theta negative means third and the fourth quadrant. So the other two normals will be in the third and the fourth quadrant. So 3 normals in all. Clear? PQ is a focal chord of the ellipse. This is an ellipse x squared by 25 plus y squared by 16 equal to 1. Okay, the center is C 0 0 and they've already given the focus S 3 0. So there are, you could have also obtained it from this, the focus AE and minus AE could have been obtained directly. So well, if they have given, why not take it? And y x can go up to 5. So this is 5 units, the major axis of the ellipse, right? This is 3 units. What we are seeking is, if PS is 2, then the length of the chord PQ. The point P is selected on the ellipse such that PS is 2. Realize this is 2. Then the point P must be this. You don't have to do any calculations. Then the point P must be this, isn't it? So PS is 2. So what is it that we need to find? The length of the chord PQ. PQ would be this. This must be the chord, isn't it? If this is one extremity, this must be the chord. So 10 units would be the length of the chord PQ. Right? Fx is known to be a decreasing function of x. Fx is known to be a decreasing function of x. And there is an ellipse which is x squared by f of k squared plus 2k plus 5 plus y squared by f of k plus 11 equal to 1. Now we want the major axis to be the x-axis. We want the major axis to be the x-axis. That means the line y equal to 0. That means if we want the major axis to be the x-axis, that means this f must be greater than this. This must be greater than this. That means f of k squared plus 2k plus 5 must be greater than f of k plus 11. But f is a decreasing function of x. So if f of this is more than this, then this must be less than this. That means k squared plus 2k plus 5 must be less than k plus 11. Such must be k. Or k squared plus k minus 6 must be less than 0. Or k plus 3 into k minus 2 must be less than 0. And wavy curve method, minus 3, 2. This is the wavy curve. So k must lie in the interval minus 3 to 2. K must belong to the interval minus 3 to 2. Yes or no? 3x squared plus 4y squared minus 18x plus 16y plus 43 equal to C. Let us examine this. Let me combine these two. 3 into x squared minus 6x. These two. 4 into y squared minus 16y. 4y plus 43 equal to C. Okay. Now this I can write as 3 into x minus 3 whole square. I'll balance whatever remains. 4 into y minus 2 whole square. 16 and 27. Oh, this was plus 16y? Plus. Okay, plus. Plus. Right? So 9, 27, 4, 4, 16, 43 all consumed. This 43 got consumed. This equal to C. Alright. Let's now look at the options. Cannot represent a pair of straight lines for any value of C. See, C will either be positive or negative or 0. Suppose C is positive, then x minus 3 whole squared by C by 3, 4 into y plus 2 whole squared, C by 4 equal to 1 will be an ellipse for a positive C. If C is 0, so if C greater than 0, it will represent an ellipse. If C is equal to 0, it will represent a point 3 comma minus 2. If C is less than 0, it will represent a null set. No, it will represent a null set because this is non-negative, this is non-negative. So if C is negative, then how can a non-negative number be equal to a negative number? So C less than 0 will represent a null set. It will represent Babaji ka Thullu. Right? Nothing. Huh? C less than 0 will represent a null set. Nothing. C equal to 0 will represent a point 3 comma minus 2. C greater than 0 will represent an ellipse. Right? And under no circumstances will it represent a pair of straight lines. So let's look at the option. A, yes. B represents an ellipse. C greater than 0, true. Empty set, null set, C less than 0, a point if C equal to 0. That's the point. Right? Let's look at the next problem. Khatam? Stand by. One sec.